We are officially beginning Unit 5, and we're going to start by looking at the finite differences and quadratic relations. So finite differences are something that we have worked on before, and it's something you've done a lot of in grade 9. So we're going to start by doing a bit of a recap to help you remember how to work with finite differences. So as a reminder, finite differences are the differences found from the y values with evenly separated x values. So the fact that our x values are evenly separated is very important in getting an accurate answer from our first differences. So first differences specifically, not just finite differences in general, are the differences between consecutive y values. And that word consecutive means one after the other. So if I'm looking at 1, 2, 3, those are examples of consecutive numbers. Now, the part that's new this year are second differences. And second differences are the differences between consecutive first differences. So all of those words can be a little confusing and a little wordy. So the best way to refresh our memories is to do some examples. So the first thing we're going to do is we're going to complete these tables to determine if each relation is linear. So we're going to start by completing the tables. And we haven't done this in a while, so it's going to be a little bit of a review from grade 9. So when I'm completing a table of values, I'm going to look in this first row here, and because I have -2 in my x column, in my y column, instead of writing an x, I'm just going to write a -2. And now I can simplify that. So 2 times -2 is -4, minus 5 will give me -9. And I'm going to continue that all the way down the column. So for my second row, I have a -1 over here. So instead of writing a -2 in for x, I'm going to write a -1. And that will give me -7. For the next row, because I have a 0 here, instead of writing an x, I'm going to write a 0. So we get y equals -5. For my next row, instead of writing an x, we're going to write a 1. So that will give us -3. And then for our last one, instead of writing an x, we're going to write a 2, and that will give us -1. So now we're going to work on our differences. And when we do first differences, we're going to take our y value and subtract it from the one above it. So the first one will be -7 minus -9. So that will give us 2. And now you're going to continue to do this on all of your y values. So we'll take our -5 and we'll subtract it from -7. And that will also give us 2. Same idea with the next one. -3 minus -5 will also give us 2. Then we have -1 minus -3, which also gives us 2. So the next part of the question was to determine if our relation was linear. And for this example, the relation is linear. And we know that because all of our first differences are the same. So because I have 2, 2, 2, 2, I know that this is a linear relation. So I want you to give the second one a try on your own. Pause the video, give it a try, and then come back and double check your answers and see how that went. So again, for this example, we have the same first differences. So we can make our conclusion that this is a linear relation because our first differences are the same. So those are really your steps, and these are the steps that you did in grade 9. So just to sum those up, what is true about the first differences for a linear relation? We know that they are the same. If the first differences are positive, what do I know about my slope? That's going to tell me that my slope is positive. So just like our first example, because my differences were all positive 2, it's telling me that my slope is positive 2. If my first differences are all negative, it's telling me that my slope is negative. Just like the second example, all of my differences are negative 6, so it's telling me that my slope is negative 6. So my line would look something like that. So that part is the grade 9 part. So it's totally okay if you don't really remember how to do it, but hopefully it's a little bit familiar at this point. So we're going to take this to the next step and we're going to bring it to the grade 10 level. So we're actually going to do the exact same thing here, and we're going to fill in our table of values, and then we're going to find some differences. So I'm going to start by filling in the first table of values, and we'll do the whole example together, and then I'll give you some time to try the other ones. So the first thing we need to do is we need to complete this table of values, and we're going to do that in the exact same way that we did the last one. So because there's a negative 2 over here in my equation, I'm just going to write a negative 2 instead of an x. So I should get 4. For the next row, instead of an x, I'm just going to put a negative 1, y equals negative 1 squared. So I will just get 1. And we will continue like this. So for this one, we'll put a 0 in for x. For my next one, we'll put in a 1 for x. And for our last one, we'll put in a 2 for x. So the next thing we're going to do is we're going to find those first differences again, just like we did before. So the exact same steps that we did in the previous example. So I'm going to take my y values and I'm going to subtract it from the one above it. So in this case, I have 1 minus 4, which is going to be negative 3. Again over here, 0 minus 1 is going to give me negative 1. Again, 1 minus 0 is going to give me 1. And then we have 4 minus 1, which is going to give me 3. Now, if I look at these numbers, my first differences do not match. And that is okay. So in grade 9, you would have looked at that and you would have said, okay, it's not linear. So for grade 10, we're going to look at that and say, okay, it's not linear, but I need to check for something else. So what we're going to do is we're going to find the second differences. So I'm going to do the exact same thing with the numbers we just found. So I'm going to take negative 1 and I'm going to subtract it from negative 3. So negative 1 minus negative 3, and that will give me 2. I'll do the same thing over here. 1 minus negative 1 also gives me 2. Then we have 3 minus 1 also gives me 2. So what we found here is that the matching comes from our second differences. So we'll do one more together and then I'll give you an opportunity to try them on your own. So this one down here, we're going to do the same thing. We're going to fill in our table of values first. So for our first row, instead of writing a x, we're going to put a -2, and that will give us 10. For our second row, instead of writing a -1, instead of writing an x, we'll put a -1, so that will give us 4. And if you continue on, you should get these numbers. You can do those in your calculator, but just for the purposes of time, I'm just going to go through them a little quicker. And then what we'll do is we'll do our first differences the same way we were before. So we take the bottom one and subtract it from the top. And again. And again. Now what I notice is that my first differences don't match, which means I will be moving on to my second differences. So we'll do all of this again with the pink numbers. So -2 minus -6, which gives us 4. 2 minus -2 also gives us 4. And then we will have 6 minus 2, which also gives us 4. So what I've noticed here is I have matching second differences again. So what I want you to do is quickly try the other two, pause the video, give them a try, and then come back and check your answers. So if you go through, you'll notice that for all of these examples, our second differences match. So now we want to make some conclusions. So go through and quickly graph those. Using our points, they should look something like this. So once you have your graphs, we can make some conclusions. So here are the conclusions that we really want to get out of this. And we're going to practice with graphing. So if the graphing went really fast, don't stress about it because we're going to be doing lessons and lessons about graphing. So the first thing we want to look at is what's true about the second difference of all quadratic relations. They are all the same. So in grade 9, all your first differences were the same. In grade 10, all of your second differences are the same. When our second differences were positive, then the graph opened up. And when our second differences were negative, my graph opens down. So in the previous unit, we were looking at quadratic expressions. So we always had ax squared plus bx plus c. And now we're going to look at what's called a quadratic relation. And that is similar to how you were looking at linear relations last year, but now with those quadratic expressions. And this form is what we call standard form. So the graphs that we'll be looking at throughout this unit are always U-shaped and symmetrical. And they're called parabolas. That's what we'll be looking at. So there's a few important little pieces that we're going to talk about. So the first thing is the vertex. So it's the point where the curve changes direction. And what I mean by that is I could have something that looks like this. So that point would be a maximum point. And that maximum point happens when my parabola opens down. So it gets bigger and bigger and bigger, hits a maximum, and then turns around, starts getting lower. And I can also have parabolas that look like this that have a minimum point. And that's what happens when my parabola opens up. So it gets lower and lower and lower, hits the minimum, and then turns around. The next thing is because they're symmetric, they all have what's called the axis of symmetry. And basically what the axis of symmetry does is it splits it right in half. So if I have a parabola that looks like this, the line that splits it right in half is going to be my axis of symmetry. So a couple more words that we're going to learn, and we're going to practice all of these things, so it may sound a little overwhelming right now, but the values that x can take is called the domain, and then the values that y can take is called the range. So a few more things. Again, just like grade 9, we are looking at our intercepts. So we might be looking at our x-intercepts here and here, or we might be looking at y-intercepts, which would be here. We always need to make sure we're looking for those points. So an x-intercepts are where the graph crosses the x-axis, and the y-intercepts are where the graph crosses the y-axis. So we have a few things to practice it right here. So the first thing we want to find is our vertex. So we look for that turnaround point, which is right there at 1, -2. And then we look at our direction of opening. So in this case, it's facing up. And then we want to see, do we have a maximum or a minimum? So it gets smaller and smaller and smaller, hits its smallest point and turns around. So we have a minimum. And that minimum value is going to be, our lowest point is -2. Then for our domain are all the values that x can take. So we could have possible x values all through here. If I had a bigger piece of paper, this graph could go on forever and ever. So in that case, we write x, e, r. And what that means is x is an element of real numbers. So in normal English, it means x can really be any number possible. And now we want our range. So our range are all the possible values for y. So if I look here, all my y's go down to -2 and then up from there. So the lowest my y's could possibly be is -2. We're never going to have other values lower than -2 on the y-axis. So how I write that is that y is an element of real numbers, but y has to be bigger than or equal to 2. And we'll practice writing these domains and ranges more next lesson. So if you're feeling a little confused, don't stress. Now if I look, my number of x-intercepts, it crosses my x-axis twice. So I just write 2 here. And my value of my y-intercept, so I look for that. And that's right there at 0, -1. Now the last one we have to do is our axis of symmetry. So we're going to find the line that cuts it in half, and we just write the equation of that line. So from grade 9, we know our vertical lines are always x equals lines, and in this case, we have x equals 1. So we'll continue to practice this part tomorrow, but it's a good idea just to get a little bit familiar with the way parabolas look.